Hey Liv. All right, so I'm going to assume this is tech free, and at any stage where I think it's too complicated to do by hand, then I'll show you how to do it on the calculator. And also the mark allocation sometimes gives me a hint as to whether it's tech free or tech active. All right, let's get started. So the volume V in centimeters cubed of a cone is, okay, so this is just the formula for the volume of a cone, where R is the radius and H is the height of the cone. All right, the radius and height of the cone must total 15 centimeters. All right, sometimes I like to just draw a diagram because I can draw pictures. All right, so there's our radius and there's our height. So the radius and height of the cone must total 15 centimeters. So R plus H is equal to 15. Show that the volume is this. So notice they gave us this information so that we have the volume formula in terms of R only, not in terms of R and H. So with this R plus H equals 15, I can just rearrange it to get H is equal to 15 minus R. So that means in my volume formula, I'm just going to substitute that for H. All right, so writing it out. So we don't know what the radius is, so that's our unknown. So 1/3 pi R squared times 15 minus R. And at this point it doesn't look like what it has to look like, but I've substituted in H, okay? So I can just probably, oh, dog's going to bark. Okay, so that's times 15. So just multiplying this first term by the 15 and the R, and then we're going to have minus 1/3 pi R squared. So just multiplying this 1/3 pi R squared by 15 and by R, which I didn't do. All right, so times R. All right, tidying it up a little bit, 15 divided by 15 divided by 3 is 5. You could probably at this stage just write it down. You can assume that you're right. So I'm just going to do that. All right, so just tidied everything up. So the main thing that you would be looking at is substituting in that value for H. So everything is in terms of R. Find the value for R, which the volume of the cone is a maximum. So if you're looking at a maximum, you need to find the derivative and let it equal 0. So it's basically going to be a stationary point. So if V is equal to 5 pi R squared minus pi R cubed on 3, I'm kind of getting the feeling that this might be a tech active question, but anyway, we'll keep going. All right, so finding dV dr, so the derivative with respect to R, so that's going to be 10 pi R, and this is going to be, those 3's will cancel out, so it's just going to be pi R squared. All right, so we let that equal 0. Minus pi R squared, let it equal 0. We can take out pi R as a common factor. So I'm left with 10 minus R. So that means R is either equal to 0 or R is equal to 10. Now, you want the radius to exist, so basically can't equal 0, otherwise it wouldn't be a cone, so R is equal to 10. Now, if you could do this on your calculator, that's pretty straightforward. Derivative, and then you let it equal 0. I kind of think that might be still a tech-free question anyway. Find the maximum volume in centimeters of the cone. So we know that the maximum occurs when R is equal to 10. That means H, just going back up here, remember the two of them had to add up to 15. So that means H is equal to 5. So just substituting that into your volume formula, which was given to you. So 5 pi times 10 squared minus, actually, what am I doing? I could substitute it into there. I don't need to have H. Sorry, I'm just realizing as I go. 10 cubed over 3. So I'm substituting it into this volume formula, but you could also substitute it into our original volume formula. So the same thing, doesn't actually matter. All right, so 10 squared is 100, 5 times 100, sorry. 5 times 100 is 500, so 500 pi minus 1000 pi on 3, and it's only worth 1 mark, so that's fine, just leave it at that. And it's exact value, so even if you could use your calculator, you would have to leave it in its exact form. All right, I have no solutions to check, so let's just assume that's all right. All right, going on to question 8, which is not the best to see, but anyway, I'll give it a go. Consider the function. Okay, so I think this is 4 root x plus 2, judging by what you've written here and by the graph. All right, show the point is not on the graph, so just substituting it, which is I think what you've done. All right, the point Q is on the graph, the gradient of the graph, oh gosh, show that Q is the point 410. Okay, well you've done that. And then you needed help with C and D, so let's hope that, oh, hello pussycat. That's a bit easier to see, that's so cute. All right, the distance between P and Q is A root B units, where A and B are integers and A cannot equal 1. Find the values of A and B. All right, so looks like you've used the midpoint formula, and I'm wondering why you would use the midpoint formula. So the distance formula just comes from Pythagoras' theorem. So if you've got 2 points, let's call them x1, y1, with a little comma in between, and x2, y2, your distance formula is using Pythagoras. So this would be your x1, x2, and then this distance would be, hold on, what am I doing? Let me just start, oops, trying to erase with my pen. All right, I might draw it as a graph, might be easier. All right, so if we're doing the distance between 2 points, so let's find out where those 2 points are. So Q is 410. All right, so let's say this is 4, that's 10. So there's 1 point. And P, what was P? 0, 4. So that's going to be around here. All right, so we're finding the distance between these 2 points. Now, if we're finding the distance between 2 points, we use basically Pythagoras' theorem, and that is your distance between 2 points formula. Because when you think about it, if I was to draw a triangle, a right angle triangle, the distance between my x values is 4, and the distance between my y values is 6. So in this case, your 2 points, let's call this P, so that was 0, 4, and Q, which was 410. So when we substitute them in, we get, and it doesn't matter what order you put them in. What am I doing? 10 minus 4 squared. All right, so the difference between my y values plus the difference between my x values. So this is your a squared plus b squared. What am I doing? 4 minus 0 squared. And we can see this is equal to 6 and this is equal to 4. So my distance is 6 squared, which is 36. 4 squared is 16. So that becomes 52. And then we look for the highest square number that goes into 52, because obviously it's wanting us to simplify this surd. So I know 4 goes into 52 13 times, because, you know, deck of cards. So just simplifying that surd, so that gives us 2 root 13 as your distance. So just judging by what you've done here, it looks like the the midpoint formula, and hello pussycat again. All right, show that the line segment PQ is not a tangent to the graph of f at the point Q, which is 410. All right, so if you're looking at the tangent, so the gradient of this line, and it's great that I've graphed it, so your gradient of that line is rise over run, which is just 6 over 4, which is 3 over 2. So we need to use this information to show that it's not the same as the tangent at this point. So when you're dealing with a tangent, the gradient of your tangent, sorry, let me just go to this graph. What a tangent is a, what point are we doing it at? P, Q. All right, so I don't know where it's going to be, somewhere maybe around here. So a tangent is just a straight line that touches at this point. So the gradient of your tangent line is equal to the derivative at that point, or whatever that point is. So we just need to find the derivative. So you've written f of x there, and you've kind of started that. So you're right, you had to find the derivatives. So bring that half out. So 1/2 times 4 is 2. So we're going to have 2x to the negative 1/2. So we're reducing your power by 1, and then that 2 disappears. And then we just need to substitute in 4 because it's our x value. So 2 times 4 to the power of negative 1/2. So just dealing with this 4 to the negative 1/2, that negative means we take the reciprocal of it, and 4 to the power of 1/2 is the square root of 4. So it's going to be 2 times 1/2, which is equal to 1. Now, it says show that it's not equal, so we did the gradient before, so you can basically say 1 is not equal to 3 on 2, and that's probably enough. All right, so showing them, what is that? It's only worth 1 mark. Seems like a bit of work there for just 1 mark. All right, moving on. So question C, thank you for scanning this one, but a bit better. No pussycat though. So I'm going to assume you're right, but I might just quickly read it. So we've got the inverse of G. All right, that's fine. Just notice that you didn't find the domain. So you've got the, oh no, you have, sorry, my bad. There we go. Sorry. The following, just make sure that was right. Following sequence of transformations, okay. And then consider a different transformation which transforms the graph of g of x onto the graph of h of x. Find the possible values of a and b so that h of x is greater than 0 for x is greater than 0. Okay. So let's just rewrite what g of x is. So what's g of x? 2 over x plus 1 minus 3. All right, so what we've got here is a horizontal translation, and here we've got a vertical translation. So we want h of x to be greater than 0. So remember, h of x is, for x is greater than 0. All right. So is that the graph of that? Okay, so let's think about the graph first of all. So we have a hyperbola that has an asymptote at -3. So I might just draw that. So that's -3, and at x equals -1. So what our graph, and don't worry about the dilation factor because it's not really going to matter. So at this point, just going to make sure I get my hyperbola around the right way. sometimes I draw them the wrong way, but there we go. So there's your hyperbola, your positive hyperbola. And we want basically h of x to be greater than 0. So for x is greater than 0. So basically we want the graph, so we want this asymptote, sorry, I should say that, these asymptotes to shift so that our axis is the asymptote basically. So when our axis is the asymptote, this curve here on the right will then shift there. So that means that h of x is equal greater than 0 for x is greater than 0. When x is less than 0, it's irrelevant because it hasn't actually said anything. So we want to shift the asymptote 1 unit to the right, and then we want to shift it up. How many? 3. So we want it to go to the right one, and we want it to go up 3. So our x plus a, we want that to be x plus 1, and y plus b, we want that to shift up 3. We probably don't really need to write it into our function notation because we should be able to just put it straight into our function as it is. All right, I was actually rewriting the thing, but we only have to find a and b. So that means a is equal to 1 and b is equal to 3. So basically what we're doing is we're translating the graph to the right one, like I've shown, and moving it up 3. Now, just because I want to show you on a graph, so let's just have a quick look at Desmos if you want to. Whoops. All right, so sorry about showing you all my email, but just check there was nothing that was important. All right, so with our x, we've translated to the right. So that's going to be x minus 1. And then we've shifted it up 3, so we're going plus 3. So that's what I was talking about, function notation. So you can see with your graph for where it is positive, where x is positive, our graph is also positive. Where it's negative, it doesn't actually matter because we don't have to consider that for the question. All right, so I hope that helped. I think that was it. All right, bye.